Okay. Let's look at example 2. So still the same. You observe the solving steps. The same. So don't be confused by the complexity of the diagram. So determine the required force P, this one, needed to maintain equilibrium of pieces linkage. So equilibrium means delta U equals 0. When theta equal to 60, the spring is unstretched. When theta equal to 30, ignore the math. So without looking at the diagram, you know the changes of angle will be 30 degrees. Okay. So when the change of angle, okay, so when you have spring here, so spring will create spring force. You pull P, you pull the P. So where is this the theta? Theta is here. This theta. So initially it was 30 degrees. You want to change this one to 60. So you need to calculate how many force you need to pull this one to reach 60. Okay. This one can be applied in the machine design. When you want to do some automation work, you ask the computer to detect changes of angle. Okay, so when you pull P, the scissor here will straight. It will go PE, the distance here will decrease. And what happened to the spring? The spring will move to the right. Spring will move to the right. And you see as the linkage, you just maintain on the scissor, remove all the connection. Okay, now before you solve, you need to see as in the free body diagram. So this one is a ring free body diagram. Forces in G will be pointing to the X direction to the right. You have GX. Okay, you have one GX. A with a pin, free to rotate. So there's a moment, no moment, but because it's a pin, so pin, you can put in AX or AY, or you want to be convenient, you just follow this member. There's a force following the member AC. Same with here, there's a force following G to E or G to P. Okay. And then you imagine you are this V point. When you pull P, what do you feel? You feel something punching in or pulling out. You are P, right? P. So you move to the left. This one will pull you up. You feel spring pull you. So there's a spring force. Okay. Spring force, how to calculate spring force? F spring equal to Kx. Okay. So again, you don't need when you draw the free body diagram, you don't need to write the full equation, but you need to able to identify what are the forces we have. For example, the connection force, the connector force, and also the spring force. Okay. After you do that, only you go for the imagination. So you predict the motion, then you observe what will do work in the diagram. Then you solve for the equation. Okay, free body diagram, looks something like this. Ignore the gray color first. Okay, so if you are the link member, your GX, we just assume pointing up. Just assume pointing up. You can assume pointing to the right also can. It's just that when you get negative, when you do analysis, you will get negative effect. Right? So this one, you just imagine in this one, this pin here. Right? So imagine to the left, AX also to the right, AY go down. Of course, you can put AY put up if you want. and fs is to the left, p is to the right. Then you put in all the measurement. Try to observe the x direction or x distance or dimension. We do not put in the numbers. We just give it a name. For example, xd. Xd means from the reference point, this reference point, A as the reference point. From this location to distance B, we just put xd. Same with here, the pin here. So A to B point, we just label as xd. Okay. Now, how do you know which one to put distance? How do we know? The distance that we put either xe or xd is always giving you the distance to the force. The distance to the force. Okay, so if you convert the left-hand diagram to right-hand diagram, there are only 4 forces or 5 forces on the diagram. And you put the rod, the GA rod as a reference. So this GX and AX, you no need to worry. The distance to B, distance to D, distance to B, distance to P is what we need to focus on. So that's why you put XD and XE here. Okay, then copy the angle. Copy the angle. So A cannot move, so you just copy the angle. Then only you go to the virtual work. You imagine how it works. You pull P, so G will shift down. G will shift down. The body will swing a little bit. Fx will move a little bit. Okay, Fx will move in this direction. There's a changes of angle. So just remember when you have a pin, another point will move in a circular motion. So circular motion, you can use this section as equal to r theta. So there's small changes of delta theta here. This is for the pin rotation. And there's a distance of original D point to the left, delta x. Okay, to the right, sorry, to the right now. P will move to the right. Okay, D point will move to the right, but the member of AC will rotate. Member of AC will rotate. Okay, so it can develop a system where you look at the forces first. Look at the forces where the distance, any point is moving in a straight line, move up, move down. After that, then only you go to the angle. Then you see any member have a change of angle, right? So point P will move to the right at the distance of delta xt. Okay, so what force will do work? Ax, Ay do not do work. Gx, although Gx move down, but why Gx do not do work? Why? What is the definition of work? Force must go parallel with the distance. If force go perpendicular, 0, no work done. So Gx move perpendicular now, so no work done by Gx. Although Gx moving, but it's moving perpendicular, so no work done by the Gx. P will do work. P move to the right. Distance also move to the right, so it generate positive work by P. Spring will do negative work because force push to the left, but distance move to the right. So spring will do negative work. So just highlight there. Once you identify which work that do work, and Fs do work. Okay, so this one is try to find everything in angle. So arbitrary theta within this one, you put the distance of theta in the trigonometry things. Spring stretch, maybe this one, your XP. Okay. So this, when they change the angle, you get 0.3 sine, which is this distance. XB equal to 0.3 sine theta. At the equation, we do not put in the 60. 60 means the end angle. So XB is 0.3 sine theta. But we want to find this angle. We want to find delta XB. So how do you find delta XB? Delta XB is the total length of XB minus the original length of this one. So this is force, spring, speed. Okay. So before it stretch, it's before stretch. So we just put XB. You know that the length is 0.3. So here and here, this side theta equal to XB 0.3. So XB equal to 0.3 sine theta. So you want to know how long the spring is stretching. You take the end point, when you pull the P, this one will increase. So you don't know the angle first. Although the question already gives you 60. So we take the maximum angle you can go minus the original one. You get the delta XB, the change of this one. Delta XB. Yeah. So that's why you get it. Okay. Force equal to kx. So this one we know. So K is given kilonewton over meter. So you put in the changes of x traveled. So you arrive at one equation. The force is in theta. Okay. The virtual displacement to XB equal XB and XB. So this one we already calculate. XB equal to 0.3 sine theta by using this formula. XD also same. XD is from here to here. So here to here, we have three triangular. Here to here, we have one triangular, two triangular, three triangular. These are the same length. 0.3, 0.3. Okay, 0.3, 0.3. So same side angle. So you have a three triangular or three base triangular equal to XD. Okay. So this is the base of the triangular. Who don't understand how to get this one? Who are lost? You don't know how to get it. Yeah. Okay. So it means this one triangular, two triangular, three triangular. Okay. Then you do differentiation. dy dx. dxb over delta theta. So this one is a constant, but sine become cos, and then you pull your delta theta to the right side. Same with here. Constant remain. Sine, we differentiate become cos. Yeah. Then you get these two equations. Yeah. You write what is xd, what is xd, then you do dy dx or differentiation with angle. You arrive at this equation. We need this one because we are doing virtual work later. We need xg, xd, and delta xd, delta xd to do the calculation. So once you get this one, you write virtual work equals 0. We only have two forces that's doing work. So write the general equation for work first. So E multiplied by the distance traveled plus, not plus negative F and the distance traveled equals 0. So then you substitute back what is the force of spring, what is the delta xp, P you just copy delta W, you need to find out. Sorry, not delta W. This should be what? What should I write here? Typo error here. What should I write beside P? P what? P what? X what? X? XP? Where got XP? XD, yeah? Okay, so typo error. Not delta Y, it's typo error. I forget to change it. Okay, but you understand the principle, how the calculation works. Then you substitute back all the delta, and you're seeing theta there. Group them in sine and cos first. Then only you move. Just remember tangent equal to sine divided by cos. So you can move sine divided by cos if needed. Then only you solve for it. Okay, so there's a lengthy work. So you will come to a stage where, because equal to 0, so you will come to a stage where you bracket something, bracket cos delta theta. So you delta theta cannot be 0. So another things, and the rest of the things you'll get P equal to this one. Yeah. So you arrange them in cos terms of the delta term. So this one you have same one. Okay, you just factor out. This one is factor, pull up. Then you rearrange back. So cos theta, delta theta not equal 0. Then only you substitute that. Then only you substitute theta when it's 60 degrees. E is 123 meters. Okay. So as long as you follow these 5 steps right on the whiteboard here, no matter how the question asks you, there will be one unknown missing when you solve the equation. They'll show something missing in the general equation. Go and find it. Okay. So only I need to highlight this one. There'll be one step that you bracket equals 0. One cannot be 0. Another one must be 0. So this one is 0. Then you substitute. Example 3, your homework. Let's see. This one will be either in your test 2 or in your final exam. That kind of standard. This one is a final exam standard. Homework. Example 4 also go and see your homework. All the answer is there. Okay. This one This one we do tomorrow. Observation of us. Okay, we stop here. Sign your attendance, sign your attendance.